Okay class, so sekarang let us try together one question in our tutorial 3. We refer to question 8A. Kita cuba tengok 8A bersama. So we are given figure 2 show 3 resistor connected with a battery of EMF 12 volt and negligible internal resistance, so means that the internal resistance is 0. So calculate the total resistance in the circuit. So we want to find the total resistance. And then number 2, calculate the voltage across the 8 ohm resistor. So we want to find what is the current that passes through 8 ohm resistor. So I label this one as R1, this is our R2, and 6 ohm as our R3. So we are going to, in order to find the total resistance, we have to simplify our circuit lah. So if you notice, this is our this is our R1, and then this is our R2. So you can see very obviously, R1 and R2 have two leads connected. So R1 and R2 are in parallel. So I can simplify the circuit, I redraw it. So I can combine R1 and R2 into one resistor, R12. Then I still have the R3. Okay, and then you can see obviously this is your R12, and then this is our R3. So we will find out that we only have one lead connected. So it means that R12 and R3 is in series. So again, I simplify it. Finally, I only have one single resistor left in the circuit. And this single resistor left in the circuit is what we call the total resistance or the effective resistance of the circuit. So now I'm going to calculate the value. So R1 and R2 is in parallel. So R1 parallel with R2. So I'm going to have 1 over R12 will be 1 over R1 plus 1 over R2. So I'm going to have value 1 over 5 plus 1 over 8. So I'm going to have R12 will be, if you calculate correctly, you will get 3.08 ohm. Okay, after that, R12 and R3 is in series. So R12 is series with R3, So I'm going to have R effective, or the total resistance will be R12 plus R3. So I'm going to have 3.08 plus R3 is 6 ohm. So plus 6. So I'll get the value is 9.08 ohm. So this is the total resistance in the circuit. So we have done with question 1. The second question, we want to calculate the voltage across the 8 ohm resistor. So this is our 8 ohm resistor. We denote it by R2. So we want to find the voltage here. We want to find the voltage across the 8 ohm resistor. I denote it at V2. So class, before we can find the current and also the voltage across each resistor, after we calculate the total resistance, we have to calculate the total current that will flow in the circuit. With the total voltage is 12 volt, and we already get the total resistance 9.08 ohm. So we find the current first. The current that can flow or supply from the battery. Okay, so we have Ohm's law, V equal to IR. So our voltage, total voltage supply is 12 volt. current, the total resistance is 9.08. So I'll get the current that flow from the battery to all the resistor will be 1.32 ampere. Okay, so after I get that one, so this current, so you tengok, then you move backward. Macam kita buat untuk capacitor. Then we move backward. So R12 and R3 is connected in series. So in series, apa yang sama? So yang in series, current adalah sama. So kita bawa current ke sini lah. So maksudnya current 1.32 ampere yang keluar dari bateri ni, dia akan lalu R12 dan juga R3. So dia akan lalu R12 dan juga R3. So saya boleh cari V12. So V12 will be I multiplied with R12. Nampak? Daripada sini. So, current yang lalu R12, resistor combination 1 and 2 adalah 1.32. The resistance R12 adalah 3.08. So, 3.08. So, I'll get the voltage V12. V12 will be 4.07 volt. Okay, 4.07 volt. Okay, so class. Then V12. So you focus on resistance 1 and 2. So you perhatikan resistance 1 and resistance 2 adalah connect in parallel. So parallel, apa yang sama? So untuk parallel, voltage adalah sama. So, maksudnya, voltage across resistance 1 adalah sama dengan voltage across resistance 2. So, it means that V1 equal to V2 equal to V12. So, tadi dah kira V12. So, V12 is 4.07 volt. So, maksudnya V2 kita adalah 4.07 volt. So, maksudnya saya dah dapat selesaikan soalan ni lah. So, the voltage that across the 8 ohm resistor will be 4.07. So, I continue it here. So, since R1 is parallel with R2, so it means that the voltage V2 will be equal to voltage V1 will equal to the voltage 1, 2. The voltage that for resistance 1 and 2 is the same. So V12 will equal to V2 will be equal to V12, so the value will be 4.07 volt. So this one will be our answer lah, the voltage across the 8 ohm resistor. Okay. So class, through the discussion of the example and also the solution on question 8a, I hope you get the idea how to apply the concept for resistor connect in series and parallel, and also how to calculate the power or the energy in a resistor. So I want you to try to solve question 8b, 7, 11 and 12 in your tutorial 3, and then submit your answer through Google Classroom before next Sunday, 14 February 2021. Remember, the more we practice, the more better is our understanding. Thank you, class. See you on next Sunday on the next online videos about learning outcome 3.6 Kirchhoff law.